So that last video cut me off there, but if you continue to draw it, we would see that we've got an oval shape here. So, and since cosine and sine have a period of 2 pi, we also know that this would repeat going around this graph here. So let me pause the video here to get us ready for the next part of the notes. Okay. So now we want to convert from this set of parametric equations into a single Cartesian equation. So to do that, remember that Cartesian equations are in xy form, and so we want to get no more t's, just x's and y's in a single equation. So to do that, we solve one of our equations for t, and then substitute in place of t in the other equation. So I'll show you how we do that. So this says x of t and this says y of t. Just treat them as x and y. So we want to solve one of the equations for t and then plug it into the other. Now this one looks easier to solve for t because I just have a regular t here and a t squared over here, so I don't want to mess with that one yet. So solve this one for t, subtract 2 from both sides. We have y minus 2 equals t. So now this one is solved for t, so we'll substitute that in place of t in our other equation. That would give us x equals y minus 2 squared plus 1. We'll FOIL that out. X equals y squared minus 2y minus 2y plus 4. Don't forget to bring down that plus 1. Simplify that. Combine the 4 and the 1. And so we've got an equation in terms of just x's and y's. We've eliminated the t's. So now this is an equation as a Cartesian equation where we started with a parametric set of equations. All right, in this example, it's going to be kind of difficult, would be kind of difficult to solve for t because we have to mess with cube roots or sixth roots. You could do it, but here's a different way to do it. Notice the relationship between x and y. Y happens to be this x squared, because if you were to square t to the third, you would get t to the sixth. So you could think of it as t to the third squared. These two things are equivalent. Now, t to the third equals x. So we could just say that y equals x squared. So this would be an alternate way to do a problem like the last one. Instead of solving for t, you'd have to think about the relationship between x and y and come up with an equation that way. Last one, we're going to convert using trigonometry. See, in this situation, we've got cosines and sines. So what we're going to do is we're going to use one of the identities that we learned earlier this year, which is the first Pythagorean identity, that sine squared plus cosine squared equals 1. So what I want to do is I want to get this equation written in terms of cosine and this equation written in terms of sine. So if I were to divide both sides by 2, I would have cosine of t equals x over 2. Similar over here, divide both sides by 3, and we would get that y over 3 equals the sine of t. So now we can use our Pythagorean identity. Sine of t is y over 3. So substitute that in place of sine. Y over 3 squared. Cosine is x over 2. So we have x over 2 squared equals 1. Y over 3 times by itself makes y squared over 9. Similarly, over here, we get x squared over 4. And now if we just use the commutative property and switch those around, we would have x squared over 4 plus y squared over 9 equals 1, which is an equation of an ellipse. We've got a horizontal radius of 2 and a vertical radius of 3, and you see that on our graph that we did earlier. All right, see you in class.